Hello friends, the topic for today is collision theory of chemical reactions taken from Chemical Kinetics of Class 12. According to the theory, the reacting species taking part in a chemical reaction can give products only in case they come in contact with each other or they collide with each other. Now, the number of collisions that take place per second per unit volume of the reaction mixture is known as collision frequency. It is denoted as Z for binary collisions for gaseous reactions when the temperature conditions are ordinary, that is 298 Kelvin, pressure 1 atmosphere, is the collision frequency is 10 raised to power 25 to 10 raised to power 28. So that means that these reactions should be very fast. But many such reactions either do not proceed or are too slow. This means that it is necessary that not all collisions may lead to products. The collision among the reacting species which results in the products are known as effective collisions. And where the collision does not occur, it means that there is some barrier or obstruction which is not allowing the reaction to occur. So, in order to make these collisions effective, the reacting species have to overcome these barriers, and there are two such barriers, the energy barrier and the orientation barrier. Energy barrier is that in order to make the collisions effective, the species that take part in chemical reaction must have a certain minimum energy known as threshold energy, E0. A reactant which is having energy less than minimum energy, less than threshold energy, even if they do collide, they do not result into products. The second barrier is the orientation barrier. Orientation barrier means that the atoms of different reacting species which take part in reaction and which are to combine to form products must face each other. For example, carbon monoxide reacts with nitrogen dioxide to form carbon dioxide and nitric oxide. So in this reaction, the reactants, the carbon should be facing the oxygen of the nitrogen dioxide molecule. Only then the orientation is correct, the reacting molecules are properly oriented and reaction is going to occur. If the nitrogen oxide is facing carbon monoxide molecule in such a way that nitrogen atom is in front of carbon, reaction will not occur. Reactants are not properly oriented. Similarly, if oxygen part of carbon monoxide molecule faces this correctly placed nitrogen dioxide molecule, even then the reaction is not going to occur. For the reaction to occur, the carbon of carbon monoxide must be facing the oxygen of nitrogen dioxide. We'll take another example. This is the reaction. Methyl iodide plus aqueous potassium hydroxide forms methyl alcohol and potassium iodide. Now, the mechanism involves the nucleophilic attack of OH negative on the alkyl halide molecule, and this OH negative attack cannot take place from the side where the halogen or iodide atom is present, because this is negatively charged and it is going to repel this hydroxide molecule. So the orientation, if this is from this side, the orientation is not proper and no products will be formed. For the reactants to form products, the hydroxide nucleophile must come from a direction opposite to, from the back side of the molecule, which is having iodide on this side, then hydroxide will come from the back side. And then these are properly oriented, hydroxide ion can approach and form the product alcohol and iodide. So, of the two factors, the orientation factor and the energy factor is more significant. That is, even with the proper orientation, if the threshold energy is not what is required, then reaction is not going to occur. Now, a relation between reaction rate and collision frequency. According to collision theory, we can also come at a mathematical formula for this. So if F is the fraction of molecules whose collisions are effective and Z is the collision frequency, then rate of reaction is minus dx upon dt is equal to Z into F. Now, according to kinetic theory of gases, the fraction of molecules having energy more than a certain minimum value, known as threshold energy at a temperature T, is given by the relation F is equal to E minus EA upon RT. Now, in the present case, the threshold energy is the same as activation energy, so we can write F is equal to E raised to power minus EA upon RT for collision theory equation also. Now, rate of reaction is Z into F. So, in place of F, if we put E raised to power minus EA upon RT, we get the equation rate of reaction is equal to Z into E raised to power minus EA upon RT. Also, we know that rate of reaction is directly proportional to rate constant K. So, instead of rate, we can write rate constant, which will be equal to Z into E raised to power minus EA upon RT. And we have to also take into account the orientation factor P. So, the reaction equation will become K rate constant is equal to P orientation factor into Z collision frequency into E raised to power minus E upon RT. Now, the limitation of collision theory are that this theory generally applies for only simple gaseous reactions or solution reactions, but the reactant should be simple. And secondly, the rate constant calculated from collision theory will agree with the experimental value only if the reactants are simple and the reaction is bimolecular. For complex reactions, this theory does not agree, or the rate constant value does not agree with the experimentally calculated value. So if you like the video, please do share and subscribe.